happy Tuesday. You guys are doing so great. I checked out that quiz. I know it was a little bit tricky, and last week's content on stoichiometry and molarity was pretty complicated. So what we're gonna do this week is we're gonna actually do a bunch of review. I'm gonna re-explain and give you some more practice problems throughout the week. And we'll end with some more notes to wrap up all these ideas, because I know it is super complicated, but it's also extremely useful and important for you to understand how to do this. No matter what you do in your life, stoichiometry is incredibly important. And so we're going to jump into chemical quantities and molar conversions document. I have the assignment up right here, and I'm actually going to go through a bunch of them with you. So if you want to right now, pause what I'm saying. So press pause and open up your document. We're going to go through these together. Okay? Well, let's get started. So the first thing I have actually in front of me that's going to help is on my phone, I pulled up ptable.com, which is the periodic table. And so I'm going to be using this to calculate molar mass. It's super helpful. And I also have my my calculator. So let's get started. Question 1 says, what's the molar mass of sucrose? Okay. And I'm going to write the formula up here. It is, I'm going to try and write it big so that you can see it, C12H22O11. Okay, and so you need to tell me what the molar mass of one molecule of sucrose is. And here's how you do that. Okay, we're going to break it down into all the elements that we have, and we're going to figure out, or just look up on the periodic table, what is the molar mass of each of those elements. So I'm going to look here, and it says that carbon is 12.011 grams per mole. Okay, that's what it says right here. I zoomed way in. I don't know if you can see my phone, but it's right there. We're going to look over at hydrogen to see what the molar mass of hydrogen is. And if I zoom way in, it is 1.008 grams per mole. And then finally, oxygen is going to be, if I zoom way over here, 15.999 grams per mole. Okay? And we're not actually done. What we need to do is make sure we take into account how many carbons, how many hydrogens, and how many oxygens are in that compound. So I'm going to multiply each of these molar masses by the coefficient for the appropriate element. So 12.011 grams per mole times 12, 1.008 grams per mole times 22, and then 15.999 times 11, because there's 11 oxygens. And if we do the math, I don't know, I'm going to use my calculator. And we're going to get 144.132, 22.176 for hydrogen, and for oxygen, 175.989. Then we add those three numbers together to get the molar mass of the whole compound. So the molar mass of sucrose is 342.297 grams per mole. Don't forget your units, or I'll be grumpy. You always remember your units. The next thing that we're going to do is we're going to look at question 2, and it's a bunch of parts. And so we're going to have to determine, is this going to be a formula unit or a molecule? And I'm going to write up here a really easy key for you to be able to figure that out. Here's how we figure out if it's a formula unit or a molecule. Okay? Formula unit is only for ionic compounds. And what's the other word I use? Molecule is for covalent compounds. So we learned back in when we used to go to class together the difference between ionic and covalent. Okay, so if it's a covalent compound, we're going to call it a molecule. You'll circle molecule or underline it or however you want to indicate that. If it's an ionic compound, you'll say formula unit. Oh, you want me to tell you what the difference is? Okay, so here's how you tell if it's different. An ionic compound is a metal bonded to a non-metal. And a covalent compound is two non-metals. Okay, that's how you know the difference. So there you go. For question A, we need to figure out, is this a formula unit or is it a molecule, and calculate the molar mass. So here's how we're going to do that. And we're going to do the same process for all of these, all the way to question J. You're like, thanks, Mr. Talley, for all this practice. I'm so excited. You're welcome. Let's do question A together. It says phosphorus pentachloride. And so phosphorus, I know, is a P. I'm actually looking at my periodic table in case I forget, because I don't always remember. And penta, I'm thinking back, it was written on the whiteboard in class. Penta, like the pentagon, is 5-sided. So whatever this is, it's going to be 5. It is chloride, so PCl5. Okay. And we need to figure out what the molar mass is. So you have to look at your periodic table. Phosphorus is going to be 30.974, and chlorine is, let's go over to chlorine, 35.45. We're going to multiply phosphorus by 1 because it doesn't have a subscript, so there's only one of them. But chlorine has a 5 subscript, so we're going to multiply chlorine by 5, and we're going to get whatever we get when we use our calculator. 30.974 times 1 plus 35.45 times 5, because I want to add them all together. And I end up with the big total of, once I add these together, I'm just doing it all in one step on my calculator, 208.224 grams per mole. Don't forget your units. I know you want to, because you're lazy. No, I'm just kidding. You're not lazy. You're awesome. I'm sorry. I shouldn't have said that. All right. So you're going to do the same thing for A, B, C. Oh, I forgot to tell you. Is this a formula unit or a molecule? Well, let's look at our periodic table. It looks like phosphorus is above that staircase, and so is chlorine. So this one's a non-metal. This guy's a non-metal. That means it's covalent, which means this is a molecule. Molecule. Blam. There's your answer. That's how you're going to do it. Let's do another one that's trickier. Let's go over to question F. So right across next to phosphorus pentachloride. This one is copper 2 chloride. So we know it's copper and chloride, and there's 2 of them because copper has a +2 charge and chlorine has a -1 charge, so we need 2 -1s to balance out that positive charge and get a neutral compound. We talked about that in the last unit. I know it was tricky. Is this a formula unit or a molecule? Well, is copper a metal or a non-metal? Oh, it's a metal. So that means this guy is ionic, which means it's a formula unit. Blam. Okay, now let's calculate molar mass, shall we? Copper is our first chemical, and chlorine is our second chemical. Copper is, if I look at my periodic table, the molar mass of copper is 63.546, and chlorine, we did this one already, but just to be sure, it's 35.45. And we need to multiply this number that we got from the periodic table by the number that's the subscript. We'll multiply copper by 1 because there's just one of them, and chlorine by 2. Then I'm going to add all these together. So I'm going to do 63.546 times 1 plus 35.45 times 2, and I'm going to get a grand total of 134.446 grams per mole. Okay, so now we've done a formula unit example and a molecule example. What I'm going to do is I'm going to go down to question 3, and I'm going to do that, but you need to pause right now and finish all of these practice, okay, so that you feel comfortable calculating the molar mass and telling me if it's a formula unit or a molecule. Question 3 is tricky, but I love it because you got to think. So let's check it out. It says, how many moles is 4.5 times 10 to the 26 molecules of water? Okay, so I have to remember my stoichiometry road map. I'm in molecules of water and I need to go to moles. Okay, so let's write down what they gave us. 4.5 times 10 to the 26 molecules of water. Okay, and I need to convert this to moles. So what I'm going to do is I'm going to multiply number of particles, right, number of molecules, to moles of water. So number of particles of water to moles of water. Is there a numerical relationship between number of particles, number of things, and a mole? How many things is a mole? Yeah, it's 6.02 times 10 to the 23. So we'll put 6.02 times 10 to the 23 on the bottom. 6.02 times 10 to the 23, number of things to 1 mole. Right? It's like a big dozen. A dozen is 12 things. A mole is heck of things. Okay, we'll do the math because we're trying to get to moles. We don't have to go anymore. We don't have to do any more steps. And I can't really do this one in my head, so I'm going to do 4.5 second EE 26 divided by 6.02 second EE 23, and I get 747.5 moles, okay, of H2O. Feel free to check my math. I'm not perfect and I make plenty of mistakes. But let's go to question 3A. It says, how many atoms would there be? Oh my gosh, how many atoms? So if we have this many molecules of water, how many total atoms are there? Well, that's tricky. Well, let's look at water. Water has, in a molecule of water, it has 1, 2, 3 atoms, right? 2 atoms of hydrogen, 1 atom of oxygen. So what I would do is I'd take 4.5 times 10 to the 26 number of water molecules, and I know that 1 water molecule has 3 atoms because it has 2 hydrogens and 1 oxygen. And this is tricky, and we get 4.5 second EE 26 times 3 equals 1.35 times 10 to the 27 atoms. Boom. That was tricky. You had to think about it, but I liked it. It was fun. Now numbers 4 through 9 are really testing your ability to navigate through the Stoichiometry Road Map. So what you need to do is go to the Google site and open up the Stoichiometry Road Map document. That way you're going to be able to be your own navigator as you go back and forth from moles to molecules to grams to moles of something else to molecules of something else to liters and back and forth, because this is really testing your ability to do that. So I'm going to do the next one with you and then give you the rest of them as the rest of the assignment. But I know that you can do it and you have what it takes. Use your friends, use any resources you need, but you can do it. So don't give up. Just try it out. Number 4 says, how many atoms of gallium are there in 0.5 moles of gallium? Okay, so we need to calculate number, like how many particles, how many atoms. And so we always start with the number they give us. So we're starting with 0.5 moles of gallium, and we're going to convert that to number of particles. And so we'll put moles on the bottom and number, I'm just going to do number on the top. And these are both gallium, so I'm not going to have to write gallium. We know that 1 mole is equivalent to 6.02 times 10 to the 23 number of atoms of gallium. So let's do the calculation. 0.5 times 6.02 second EE23. Boom, we get 3.01 times 10 to the 23 atoms of gallium. Woohoo! That was so fun. I want to do number 5 with you. Let's keep on going. We're on a roll. Chemistry's great. Okay. Number 5 says, what is the mass of 2.0 moles of nitrogen gas? What's the mass? Okay, so we need to go from moles of nitrogen to mass of nitrogen. Well, let's figure this out. We're always going to start with what we're given, 2.0 moles of nitrogen. I know that 1 mole of nitrogen can be related to the mass of nitrogen by the molar mass. So we just got to figure out what the molar mass of nitrogen gas is. Let's go to our periodic table. Nitrogen by itself is 14 grams per mole, but nitrogen gas is diatomic, so there's 2 of them. So we need to multiply that by 2, and we get 28 grams of nitrogen gas is 1 mole of nitrogen gas. So now we can do our math. 2 times 28 equals 56 grams of nitrogen gas. We're cruising. We're having fun. I'm going to do the next one. Let's do number 6 together. Okay. Number 6 says how many molecules are in 4.0 moles of carbon dioxide. I know carbon dioxide is a molecule. It is a molecule, right? Because it's covalent. It's a covalent compound, so it is a molecule. I don't have to calculate number of atoms. I don't have to calculate number of carbons and oxygens. I just need the number of molecules of carbon dioxide. So let's start with what we're given. 4 moles of CO2, and I need to convert that to number of molecules. So 1 mole of CO2 is 6.02 times 10 to the 23 number of CO2. And that's going to give us whatever we get from calculating that. 4 times 6.02 second EE23. We get 2.4 times 10 to the 24 number of carbon dioxide molecules. We're on a roll. I don't even want to stop. Let's do number 7. This is so much fun. I'm having a blast. I know you are too. Number 7 says, how many moles are in 13.5 grams of magnesium chloride? Well, let's start with what we're given, and we'll pause if we need to calculate anything. 13.5 grams of MgCl2, and I know it's 2 because magnesium is in column 2A. It has a 2+ charge. Chlorine in column 7A has a -1 charge. So we need 2 chlorines to balance out the positive 2 charge of magnesium to get a neutral compound, a neutral formula unit. Because this is ionic, right? And so let's convert the grams of MgCl2 to the moles of MgCl2. So this is the moles. Uh-oh, I don't know what the molar mass is. Let's turn to our periodic table. Magnesium is, so Mg is 24.3 grams per mole. And chlorine, which we've used a few times, I'm pretty sure it's 35.45. I always get confused. Let's look. Yeah, 35.45. But there's 2 chlorine, so we need to multiply that by 2. We only multiply that by 1. Let's add them together. 24.3 times 1 plus 35.45 times 2. And we get a grand total of 95.2 grams per mole. So we'll put 95.2 on the bottom, 1 mole on the top. And we get, let's do the math, 13.5 divided by 95.2, and we end up with 0.142 moles of MgCl2. Awesome. I don't want to do them all for you because I know that you're going to miss out if I do them all. So I'm going to let you finish the rest of this by yourself, and make sure you submit either a picture or the digital copy on Google Classroom. You gotta do it because I've been putting in assignments. I've been putting in grades for assignments, so make sure you're turning them in. If you haven't turned them in for some reason, just send me an email and I will look at them for you. You're awesome. Have a great day. I wish we were in class.